Hello viewers, welcome to math class. We want to find LCM of these numbers, and also we'll be trying to find HCF of some other given numbers or maybe the same numbers. My student is already in class and she has attempted it, so we just want to see if our calculation is correct or incorrect. Alright, can you hear me now? Can you hear me now?
Yes, sir.
Okay, so let's quickly check together now and see if your work is intact or needs any adjustment. We're finding LCM, and you remember that for LCM, you have to divide all through to until you reach number one, where nothing can divide again. So if I have 30 and 45, I'll firstly check on even number. Even number can divide, number 2 can divide 30 because it's even number. But it cannot divide 45, so I will rewrite it. Is that clear?
Yes, sir.
You divided, indeed. You said 2 in this, but you wrote 14, okay, right?
Oh,
And that's because you counted 30, fine. You were grouping it in twos, but you made a mistake at the end. But you don't need to go through that stress. What did I say? You don't need to go through that. All you need is 3. Even if you don't know whatever, just count 3. 1, 2, 3. Now divide by 2. How many 2? Only 1. You write the 1, okay? Now it remains what? 1. You put it here to make 10. Is that clear?
yes.
Do you understand now? So you now count your 10. 1,
Yes.
2, 3, 4, 5, 6, 7, 8, 9, 10. That's easier. You now group it in 2. 1, 2, 3, 4, 5. That's where you put 5, okay?
Okay.
But 2 cannot divide this. So you leave it as 45 because it will have a remainder. But because it will not have a remainder here, that's why I divided, okay?
Okay.
So I continue from here. 3 can divide both of them. 3 in 15 is 5, but 3 in 4 is 1 remainder 1. 3 in 15 now is 5. 3 can still go in one of them. 3 cannot go in 5, but it can go in 15 to give 5, right?
Yeah.
Do you understand?
Yes.
Now what can I use? I can use 5 to get 1, 1. So that's the end. So what is the LCM this time?
2 times 3 times 5.
How many threes? So you
2.
didn't you didn't say it now. So 2 times
2.
3 times 3 times 5, right?
Yeah.
Or you said 2 times 3 squared. So what is 2 times 3? 6.
6.
What is 6 times 3?
18.
What is 18 times 5? How can you know it? Just do 10 times 5 and 8 times 5. What is 10 times 5? 50. What is 8 times 5? 40. Add 50 and 40, what do you get?
50.
That's 90, okay? Is that clear?
Yes, sir.
Now to number 2. Don't write anything, just concentrate. Number 2, we have 18 and 54. 18 and what?
4.
Again, we're going to divide until nothing can divide. So let's try 2. 2 can divide 18 without a remainder, and that's 9. 2 can divide 54 without a remainder, that's 27. How did I get 27? 2 in 5 is 2, remainder 1. 2 in 14 is 7, remainder nothing, okay? Then 2 cannot divide any of them without a remainder, so I use 3. 3 can divide 9, that will be 3. 3 can divide 27, that will be 9. I use 3 again. 3 can divide 3. 3 will divide this one. Then I use 3 again, okay?
Okay.
Then this remains 1 and this becomes 1. So what is the LCM this time?
2 times 3 square.
3 cubed, right?
3 cube. I mean, yeah.
Because it's 3 in 3 places. So 2 times 27, that's 54 because 3 cubed is 27. And how did I get that? That'll be 3 times 3 times 3, okay? All right?
Yeah.
Hold on a bit.
Okay.
All right, can you hear me now?
Yes, sir.
Now to the third one, number 3. What is number 3 question?
Um, 30 and 42.
And we're finding LCM. 2 can divide both of them without a remainder. Here I got 15, here I got 21. But 2 cannot divide them again, so I can try 3. 3 will divide this without a remainder and this. Then I can try 5, okay?
Okay.
It cannot divide this. Then I can try 7. Is that clear?
Yes, sir.
What is TLCM this time?
2 times 3 times 5 times 7.
What is 2 times 3?
6.
6 times 5? 30. 30 times
30.
7?
Yes.
210. Because 3
Yeah.
times 7 is 21. You just put a 0.
Yeah.
Okay?
Okay.
And we can try the same question finding HCF, okay? To find HCF, it's going to be a simpler step, okay?
Okay.
So let's say finding what?
HCF.
HCF. For number 1, I will do 1, then you will try the remaining ones, okay?
Okay.
So for number 1, I got this division method also 30 and 45. But the only thing about HCF is that if you remember when I was doing LCM, in as much as 2 could divide 30, I used 2, but I did not divide the 45. Can you see it?
Yes.
Are you sure you are seeing it? I used 2 to divide, but did I touch the 45 on the second step? Did I change the 45? Did I change the 45 at the second step?
Yeah.
Wait. In the first step, 30 become what in the second step? 30 became
It's
what?
15.
But did 45 become any other thing?
No.
That is to tell you that I only used the 2 for the 30, okay? And I did not touch this. It is when I realized that 2 is not useful again for this one because it will leave a remainder. That's why I used 3, okay?
Okay.
But in HCF, you can never do that. In HCF, if 2 will not divide this without a remainder, then you must not use it for this, okay?
Okay.
You must not use it for only one. You must use it for the two of them. So 2 will never divide odd number evenly. So can I still use 2 for this level?
Mm, no.
No, because I said since it will not work for both of them, don't use it, okay?
Okay.
Now I can use 3. Will 3 work for both of them? Is
Okay.
3 a factor of 30 as well as a factor of 45? The answer is yes. So how many 3 goes in 30, do you know?
Mm,
Just say 3 times what is 30?
3 times 10.
Aha, so how many 3 goes in 30?
10.
10, because 3 in 3 is 1, 3 in 0 is 0, okay?
Okay.
How many 3 in 45? Do you know what to do?
Yes.
So how many 3 in 45?
Um,
3 in 4,
9,
1. 3 in 4, 1. Remainder 1. 3 in 15, 5.
55.
So learn how to do these simple divisions, okay?
Okay.
Then will any number divide both of them again?
Mm.
Will 3 divide both of them evenly without a
Yes.
remainder?
Mm.
Hmm? Will 3 divide both of them evenly without a remainder?
Yes.
Will 3 divide both of you said yes, right?
Yeah.
So how many 3 goes in 10? Count your
2,
10 fingers. You said what?
2,
Ah, you don't know what you're saying. How many 3 goes in 10?
3.
3. Remember what?
Remainder 1.
And I said, will it divide it without a remainder? You say yes. So doesn't it leave remainder? It has a remainder, yes or no?
Yes.
So can we still use 3? Any number
No.
you must use must not leave any remainder. So can we still use 3?
No.
No. Though 3 will divide 45 without a remainder, but it won't divide 10 without a remainder. So what number can we use for both of them that will divide them without having a remainder? Can 5 divide both of them without a remainder? Can 5 divide 10? Can 5 divide 15? Are 10 and 15 multiples of 5?
Yes.
Uh-huh. That's the way you should think. So how many 5 goes in 10?
2.
2. How many 5 goes in 15? Hmm? I'm waiting. How many 5 goes in 15? Just count in 5.
3.
5, 10, then 15. How
3.
many?
3.
3. So nothing can divide both of them at the same time again. So we leave it. What's our HCF?
3 times 5.
And that's what?
15.
The meaning of HCF is that the biggest number that can divide this, and that is 15, okay? But the LCM means that the smallest number that both of them can divide, and that's 90. They can divide another number greater than 90, but they will never divide number less than 90 at a go. If 30 can divide a number less than 30, 45 will never. I mean, if 30 can divide a number less than 90, 45 will never, okay?
Okay.
At least 30 can divide 30. 30 can divide 60, yes or no? But 45 will never divide those two numbers, okay?
Okay.
That's why we can't pick them. We can only pick 90 that 45 can divide and 30 can also divide.
Yes.
Is that clear?
Yes, sir.
Okay, let me quickly attend to the remaining two so you concentrate. Okay? We
Okay.
have 18, we have 54. We're looking for the highest common factor. We're going to divide by a number that can divide both of them. 2 can divide here, 2 can divide, then 3 can divide here, right?
Mm.
You have 3 and 9. 3 can also divide them, right? You have 1 and 3, and nothing will divide them again. So what is the HCF?
2 times 3 squared.
That's what? 18. Okay?
Okay.
Then the third one, We have 30 and 42. Looking for the number, the biggest number that can divide them. So we have 2 here, 15, and 2 here, 21. 3 here, what do you have? 5 and 7. Nothing will divide them again. So what's the HCF?
2 times 3
Which
equals
is
6.
6.
6.
Okay, no problem. Write down the solution here, then I'll allow you to run this one. Do quick. Alright viewers, thanks so much for watching. You can subscribe to this channel for updates on our future videos. Goodbye for now. Alright, so we want to look at this quantitative reasoning to see how we can explain the sample so that we can find this one. If you look at these two numbers, if you find a difference, like if you find a difference, you get 10. Then you divide that difference by 2. Get 5. So that works for the first one. Let us now see if it's going to work for the second one also. We have to find the difference. Oh, no, that doesn't work because the difference here is 10. 10 over 2 should have been 5. Okay, let's try another stuff. Hmm. Let's add them together. If you add them together, you get 20 plus 10. Now be 30. Okay. Um, we can think about 30 divided by what will give us 5, and that's 6. So if we count that as the method that you add and then divide by 6, we just say 6. If 6 go for this one, then it becomes the rule. So 4 plus 14 will give us 18. Then 18 divided by 6 should give us 3. So it worked for this. Let's check if it will work for the last one. Any rule you choose must work for everything. So you can say that 48 plus 18, and that would be 66. If you divide 66 by 6, what do you get? You get 11. So it works. That means we can use it for this example. The question, one of the questions that's here. So let's try it and see if the answer is in the options. Okay, wait. I need to not cut it out. So here I said you're gonna add something together and divide by 6 to get whatever something. So I know that what I want to get over 6 is gonna give me, oh, wait a minute, the number at the center, which is 15, is gonna give me something over 6. And that something will be addition of this. So that means, the center number equal to addition of this is the addition divided by 6. So how can we get what the addition stands for? We can cross multiply. So 1 times x is x, and 15 times 6, excuse me, 10 times 6 is 60, 5 times 6 is 30. That's 90. So that means I must add this to get 90. So that if I divide 90 by 6, I'll get 15. Yeah, I must add this to get 90, and whatever I get, which is 90 divided by 6, give me 15. So that means the question mark plus 15 is 90. So 90 minus 50, the question mark plus 51 is 90. So 90 minus 51. 90 minus 51. This is 9, and this is 3, because that'll be 8 minus 5 is 3. So it means 39 should go in here, and that becomes the answer here. Okay, let's try these other ones too. But before we try that one, let's check it. Let's assume we don't have the 15 and we want to find the 15. Why am I cutting it? Let's assume we don't have the 15 and we want to find it. What we're going to do is that we're going to clear up the 15 and put our 39 and see if it's going to work. So if we cut 15 out of that spot, we're going to get to fill in the colors of that spot. Maybe I check here and I check here, or don't know, it doesn't matter. So I just fill in the color. So I'm looking for that, but then at this spot, I have 39. So I put 39 there just to cross check that one and see whether it's going to work. So this is going to be 39. So I'm going to add these two together and divide by 6 to see if it gives me 15. So that means 39 plus 15, plus 51 rather. This is 10 and this is 9, making 90. So 90 divided by 6 is going to give me 15. How? 9 here is 1, remainder 3. 930 is 5. I believe that should be clear. So we can go to the second one. The same method. We're going to say that 9 times 6, okay? And that's 54. So 54 minus 21, that will be what? 33. So the answer to that one is going to be 33. So 33 goes in here. Such that if you add these together and divide by 6, you have 21, 33, that's 54, divided by 6, go to 9. So, and the last one that I want to solve there, I got to add these together and divide by 6. 60 plus 60, that's 120. Divided by 6, that's 20. So this is going to be 20. I believe you get that. That's just like a bonus to this class for today. Goodbye for now.